So one final thing that we can do, now that we have an expression for CL1, is just return to this equation for CD alpha that we just derived when talking about the drag force. So you remember we stopped here with this equation that depends on not only CL1 but also alpha itself, right? And what we can do is use the expression that we've just derived for the lift coefficient, namely this one, to just tidy that equation up a little bit and reduce its dependence on alpha. So what we can do is take the derivative of both sides of this with respect to alpha, replace CL1 with the expression that we just found up here, and what we get is the following. So that's what I've done. I've taken a derivative of both sides with respect to alpha, and then I've replaced CL1 squared with this expression that we had up here. So remembering that that is squared, that this could become a big mess in here, but if we realize that these three terms here don't depend on alpha, so therefore would be 0 when we take the derivative, we can just replace, we can just eliminate those, and we're just left with this term. The other thing to recall is that we're just assuming that these alphas in here are not too far away from the trim alpha, right? So these are small deviations from the trim alpha. And that assumption we can use to eliminate some more terms in a moment. So I've just collected everything together for this equation and then differentiated with just using the product rule with respect to alpha. So I'm left with these two terms on the left hand side, which involve the derivative of CD alpha, and I'm left with this term on the right hand side, which is a derivative of CL alpha. And using this assumption up here, we can assume that these lift and drag coefficients with respect to alpha are approximately constant. So therefore we can eliminate those two terms and we're just left with this expression here. And finally, just using the equation that we had up here for CL1, we can rewrite this thing, eliminating alpha, to get this neater expression for CD alpha.